Hey everyone, thanks for joining me today. This video is going to be about the Subghz Demo application. It's a code walkthrough. So if you're not a developer and you don't care about looking at the code for the Subghz demo, feel free to look at some of my other videos instead. I have tutorials that are just kind of what is the Flipper Zero, and I'm going to just keep trying to create new content for both developers and for pen testers that are not developers, that just kind of want to get in there and see the data a little bit more or learn how to do different features. Go ahead and put in the comments if there's certain tutorials you'd like to see, and I'll definitely try to get to those. This video is going to be, I think, pretty darn long. The code itself is really long, so I'm going to put indexes so that you can jump around to the sections that you care about. Most people probably won't sit down and watch this video in one take. If you do, it's going to be like being in an hour-long class at school, probably. I apologize in advance. Definitely, if you have any questions and I'm not clear about stuff, or if I'm totally wrong about stuff, because I'm just learning this stuff too. I'm just trying to learn it as fast as I can and get content out there for you. Go ahead and post comments and I'll see what I can do to fix things. So the Subghz demo application, I already have another video that is this application that's running. So I would encourage you to watch that video first if you haven't. I also have another video that's the Subghz, how to add the Subghz worker library into your own application. And the README for the Subghz demo also covers how to add Subghz into your own application. So if that's what you're trying to do, those other videos are probably more helpful than this one. But if you're just like, how did that, I ran that demo and it works and I want to understand how that code works, this is why I'm making this demo. It's probably not going to get many views, and if it does, the retention time is probably not going to be that long. But again, put comments down below and say, hey, I wish there was this other tutorial that you did in Subghz or IR or whatever, GPIO, building circuits, whatever you want to do is totally cool. And I'll do my best to try to accommodate those ideas. All right, so what do we got here? We are in GitHub. I'll put the link down in the description. We are looking at this commit, which is where the version before the commit did not do any radio frequency stuff. And the version after sends messages on 433 megahertz and it receives messages on 43 megahertz. I'm going to walk through all the code, not just that RF code. Since again, if you're looking at just the RF code, I recommend the other video where I talk about how you can add Subghz into your own application. Lines in red are deleted. They were in the one that just did logging. And lines in green are added, they were not in the ones that did logging, but they were in the ones that actually did transmission. So you can see we used to say we log and now we're saying we're sending. We should probably say we log and send, but I guess that's good feedback. Yeah, if you have any code feedback, definitely drop it down below. I'm going to pause this video real quick so that I can expand all these nodes. Oh, look, there's an expand all. Nice. Learn something new. Okay, the first thing we do is all of our includes that we need. And then we also have the includes now for the Subghz TXRX worker, which allows us to do radio communications. Next, we have the name of our game, which I've chosen to be SG Demo for Subghz Demo, and followed by the colon at the end. We're doing that because we want a delimiter in our names so that similar names don't match. The tag is what I'm using for logging. So whenever I log, this shows up at the beginning in the brackets. I've seen some people use capitalization and some people use all lower, so I don't know what's the right standard. If you've seen, have an opinion, please place it down below. The next is, since we're doing RF stuff, we have to decide how many bytes we can send in one packet. So we're sending a packet and we're receiving a packet. This application I could probably drop this down to even less. For now, I'm saying we can send up to 60 bytes, which is really large for this application when you look at what the data is. I think that there's a limit on the chip that's around 60 to 64. So I don't think you should go above 64, but if you do, definitely try it. Make sure you have a second flipper, or you use the hack RF to receive your messages and then replay it. When you replay it, you can use the chat in the CLI and see your messages come back, or your app can just grab the messages and you can make sure it works. The versioning, I'm not using versioning in this app other than the send a version. When we have another version, we would change this letter from A to something else. And that way we would know which version, when we receive a packet, we'll know but which version of it was the one that sent us that packet. Next is when I'm sending packets, I'm putting a purpose on all my packets. And the reason is so that I know how to parse the data section of that message. For my purposes, I decided it's a single character, and it's like a C is for counter and a T is for tone. If I was to add other things, I would come up with different letters here, and then that's what that's for. So if maybe pressing the down button did something else and sent some different kind of message, I would add what the purpose of that message was here. Okay, so this is our event types. And so tick is every time that the timer fires, which I think is like every 250 milliseconds is the way this app is set up. The purpose is to increment the local counter. Key is whenever you press one of the buttons on the flipper, so up, down, left, right, okay, back. And then whenever we detect that there's new data available through the RF, we have this data detected event. Whenever we're trying to send a counter, so you press the OK button, we'll do this send counter. Receive counter, so whenever we got the message and then we parsed it and it's a counter is the message, then we'll do this receive counter. Send tone is the up button or the long up button. So when we press that, we want to send a tone to the other flipper, we use that. And then receive tone is when we got a message and we parsed it and we decided it was a tone we're supposed to play, then we do a receive tone. So those are the events. If we were going to expand it to do other stuff, we could add additional events here. For example, maybe we wanted confirmation, like your application is a multi-device, but it actually needs the other person to confirm it got the message. Then you could, send some kind of like acknowledge tone event, and we could do that whole thing. So when we send a tone, then we also had an acknowledge tone. And if we didn't get the acknowledge, we could resend the tone every so often. The next section is basically when we have an event, what kind of fields do we need for that event? So the first thing we need to know is that type. So we put that in here. The next thing is if it happens to be a key, then we want to use input event to know information about the key that was pressed. If it happens to be, it used to be if it was a counter, send the counter or send the tone, but now it's send the counter, send the tone, receive the counter, receive the tone. We put that value in here as an integer. I believe this is actually wrong in the comment. I think it's received counter, received tone is where we have that sender name. So comments sometimes lie. That's good to know. Next up is our application data. And so this is where you'd have like your player board, the next, move, that kind of stuff. So we have a buffer here that we're using when we're rendering our screen. We reuse this buffer over and over so we don't have to keep allocating and freeing memory. We have this local counter that's incrementing every time a tick happens. We're incrementing that local counter. And the remote counter, it changes every time it receives a counter from the other flipper. Both of these counters should be 4-digit numbers, so they should be between 0 and 9999. The remote counter we actually set to 10,000 at the beginning, which is bigger than 9999, and that way we know not to show that on the flipper screen. And that way, if other second flipper sent a 0 to us, we could actually render a 0. And we'd know that that was from the flipper, not 0 because we initialized it to 0. So we'll look at that down below a little bit later. Okay, so our context is we have our message queue, which is Every time we have an event, we are queuing those events. We have this data that we just looked at, which is about our application. We have a mutex that protects that data, so you shouldn't change this data without first acquiring that mutex, and that way multiple threads don't change the data at the same time and end up causing inconsistency through the properties. And then finally, we have our sub-gigahertz TX-RX worker, which is what we use for all of our communications in the sub-gigahertz, which is that 300 megahertz, 400 megahertz, 900 megahertz messaging that we're doing. In our case, this demo is only doing it for 33 megahertz. This is when we get new data received, the worker is going to call this method. And what this method is going to do is say new data was detected and put it in the queue. Next is once we do process this data detected event, we're going to go try to receive the data. So this method is receiving the data, which it's assumed that there's already data waiting for us. So we allocate a message, and then this length we set up above was 60 bytes. We set all of the bytes to 0, and then we try to read that message, passing it a max of 60 using our worker. And what we'll get back is the actual number of bytes that were read. If someone sent us hi in CLI chat or whatever, they sent hi on that frequency. It's not really for our app, but our app would still see the message and read it, and it would be a length of 2 saying H and then I. So next we get the game length, which is SGDEMO colon. So that's 7. So we have that 7, and we take 7 and we add 2. And the reason we're adding 2 is because after our game length is the purpose of the message and then the version. So we added 2. And we make sure that the length isn't less than that. Because if the length is less than that, if the message is hi, it's not for us. It doesn't have our game name at the beginning of it if it says hi. It should have said SG Demo colon M for a purpose or something for message, version A, and then hi, and then colon, and the name of their flipper. Then that would be our game's format if we implemented messaging. So then we look at SG Demo colon and compare it with the beginning of our message. And if it's a match, then we got a message that starts with SG Demo colon, which means we got a message that's for our app. If we didn't, we'll just ignore it. We just exit. We could have logged a trace message that said we got this other message, which might be interesting just to know what else is going on in the room. But in this case, we'll say we got that message. We see that the next thing is the purpose. And so because this is indexed at 0, if we use game length, we're 7. So 0, 1, 2, 3, 4, 5, 6, 7 puts us right here at the C. And we're going to drop that into the purpose. So the purpose is C. And if we look up above again real quick, we see C means we'll actually have a demo RF purpose counter set in that variable. And then next is the version, which we're not going to use. And that's it. One more from that length. So if we were here for C, +1 puts us at the A. We grab that version where it's unused for now. I suppose we don't need to grab the version or say unused if we're not going to use it yet, but oh well. And the message at the last index of the message, remember it starts at 0, so we subtract 1 from our maximum length, which gives us in spot 59 is the 60th byte of our message. We put a null. There should already be a null somewhere in that buffer, but I want to just be real explicit and make sure that the buffer we're about to parse is null terminated. Next, we're allocating some properties that we may need later. We switch on the purpose. So if the purpose was counter, like it was that C, like we looked at here, that we received, it was counter, then we do a string scanf with the message plus the game length plus 2. So that puts us right here. which we know that this could even be a null. What we do know is the length is at least equal to here. So this is at least a null or something. Hopefully it's the 4-digit number. So we're looking at that and we're trying to read in a 4-digit number because that's just what our protocol calls for, followed by a colon, followed by up to 8 characters for the sender name. And so the number will go into here and the sender name will go into here. And then it'll return back how many of these properties it successfully got loaded. So if maybe there was no colon or something, I think the number part might have still succeeded and you get like a 1. We definitely need the number and we also need the colon in the flipper name. So if we get 2, then we're good and we continue. So you probably would want to do an else here and do another log, maybe at the debug level saying demo purpose counter could not be parsed or something like that so that you know what's going on to make your life easier later. Okay, so we allocate a string and then we copy that sender name into the newly allocated string. Because this is just local. So if we're going to return these out to other people, we have to do allocation. This should be if it's greater than or equal to, that's a bug. So that should say if it's greater than or equal to this, then do the modulo so you get a number between, divide it by 10,000 and put in the remainder. So that'll give you a number between 0 and 9999. I'll put the equal sign, but even then the counter should have been a 4-digit number. So if we are having to do this truncation, we should probably log an error or at least a warning so that we can debug it. We're going to queue up that we received the counter and then we're going to say what the counter is and who the sender is. And we queue that message. And the next is if the purpose was instead of a C, if it was a tone, a T, then we look at the +2 and we are looking for a number, the frequency, unsigned, so not negative. But we don't have a limit. We don't have this 0-filled 4-digit kind of thing where we have just some number. So you could pass in whatever number, a colon and up to 8 characters. And that again goes here and here. We do a similar thing. We allocate. We do this. We don't have this truncation concept because this can be any frequency that someone wants. We throw that in there and we queue up the received a tone. If you had other events like we had talked about, maybe you want to add a confirmed counter received or whatever, you would add those in here, different messages that you might get back. In the default, we should probably at least log a warning that we are getting a purpose we don't understand and we don't support. As our versions, it might just be that someone else has version B of the app, which supports more things, and that's why we got it. So it's not an error, definitely a warning or a debug or something. Especially if the versions are the same, then maybe it's more critical. Next up, we have when there is a button press, this will get invoked. And when that gets invoked, what we're going to do is queue a key event, and then we're going to set that input to the key data that was sent to us. So up, down, okay, whatever. That's going to get queued. Every time the timer fires, which is a few times a second, this method's going to get called from the timer. And then we're going to queue up a tick event to say it was, the timer happened. We don't really care about the timer itself. We're not using it. There's no data. It's just, it happened. So you need to increment your local counter. If we don't increment the local counter, it's not the end of the world. So there's a 0 here. So sometimes the counter may not increment if the flipper's busy doing other things on other threads. A short press of the OK button is gonna invoke this. And what we're gonna do when someone presses the OK button with a short press is we're gonna grab that local counter and put it in counter and then say we want to send whatever that local counter value is at the time, and that'll go in the queue. The counter itself may continue to increment and it may continue to paint, but whatever value it was at the time that we got this message of the key press we're going to grab the local counter at that point. So send tone is when they press up or they hold up, where you're going to call this method. And we're going to call it with both the context and the frequency of 440 or 880, depending if it's a short or long. And then this one's going to queue up an event of sending a tone. And then what that frequency is going to be the number data that's in our event. So this is where we're drawing onto the flipper's screen. And what we do is first we're trying to acquire that mutex. We wait 0.2 of a second to try to get that mutex so that we will be able to access the data without anybody else being able to modify the data while we're accessing it. If we're unable to, then we just don't paint on this render. Hopefully the next render will be able to paint. So now that we've acquired that mutex, we are going to get the data and set our local counter to a variable and our remote. And then we are checking that these values are what we expect them. The local has to be a 4-digit number, so it's got to be 0 to 9999. And the remote counters 0 to 9999, but we also have 10,000 that don't display. So we put our font. There's a bunch of different fonts. There's primary, secondary, keyboard, and big numbers. So in this case, we're going to use primary, and we're going to have a couple of messages so the user knows what to do, because without these, it's just kind of the flipper screen's just incrementing a number real quick, and it's not obvious what you should do for this app. And then we're going to render our 4-digit counter into a string buffer. And then in the smaller font, we will position it down a little bit from here and go ahead and show that local count number. And then if we've received a remote count and we're numbered between 0 and 9999, yeah, we're going to say received in that counter, put that in the buffer, and render that below this one. Finally, since we're done with our accessing this data, we go ahead and free that mutex that we had acquired earlier. Okay. So now, every time a tick happens, we're going to go and update our local counter to be 1 bigger. So we get that. We're trying to increment that local counter. So we grab our data, we do the ++, which is going to take whatever values in local counter and make it 1 larger. If by doing that, we're no longer a 4-digit number, so we were at 9999 and we went to 10,000, we wrap it to 0. So again, this should say greater than or equal to. So that's a bug. And then we're logging at the trace level what our local counter is. This is going to be really noisy, so you want to make sure that you're using a level like trace. Next up, we have the remote counter. So when we receive an event and it has a counter in it, we want that event should be a counter between 0 and 9999. And then we want to get that number out of the event and put it in the remote counter for our application. And then we log that as an info. And so then because now this remote counter is that new value we just got sent, then this will happen, that we will be less than, like we got sent a 400 maybe, then 400 is less than this. So now we'll start saying we received a 400, and that'll just show on the screen until we receive a different value. So playing a tone, when we receive a message that says play a tone, we again get the frequency from that number. We say we're playing that frequency. This should be indented back. So that's a bug. It should be underneath here. We go ahead and wait up to a second trying to acquire the speaker. I don't know how long is reasonable length of time. Obviously a second's really long. Maybe we should have waited like a 1/10 of a second. I have no idea what else would be using the speaker at the time. So we should probably test that and try to figure out if we can make a smaller, more reasonable number for our app, like 200 milliseconds again would be nice, since our counter is incrementing every 250. This is going to potentially make the counter not get to show its value for a while. So then we set the frequency. The volume is, we wanted 100%, so that's 1. So if you wanted 50% volume, it's 0.5 F. F is for float. So we pass in that frequency and that volume, and now the speaker is playing that tone. We wait 100 milliseconds and then we stop playing the tone, and then we release the speaker. So that's how playing a tone works. You could imagine that we could change our protocol to have also durations in the messages. So instead of just saying a particular frequency to play, you could start to be able to send remote songs back and forth, which might be fun. You probably want to make sure that it's only one other flipper sending a song at a time. Yeah. So next we're looking at when we want to actually send a message to the second flipper. This is a helper method that is broadcasting that message to the second flipper. So this is the message that we want to send. We convert it over into message. We get its length. If the length is bigger than the 60 bytes, it's kind of interesting because we're the one broadcasting it. So our app should not be trying to send things larger than it's allowed. So we log an error that it's bigger than we thought. And we say how many we should be at 60, and we put the message in the log. I guess it's an error, but let's try to do our best. So what we're going to do is at the very end of that buffer, we're going to add /r/n and a null to the very end. So at the very, very end, remember it starts at 0, so we have to subtract 1. So we're going to go 60 minus 1. So at spot 59, we're going to put the 0. 58, we're going to put the /n. And 57, we're going to put the /r. So we're going to get the /r/n and a null. So it's going to hopefully be okay, but that could have ended up doing something unexpected here. Like our flipper name might not be the 8 characters we were expecting anymore or whatever, because we really should fix these output messages. Another solution would be to log this error and then to do that assert and go ahead and crash so that you know that there's an error and you can go fix it. It's kind of a question of like, do you try to do your best and keep the app running, or do you crash because you're under development and you want to fix it? Not sure what the best answer is there. Kind of matter of opinion, I think. And then finally, we just keep trying to write out on that using the worker, write out that message of that length. And if it's not true, if it hasn't written it, we wait a little bit and we try again, and we just keep trying until we finally succeed. That's what broadcasting looks like. Okay, so next we're going to look at the Subghz Demo broadcast counter. So this gets invoked when we want to send our counter, and we're going to send in the counter to send as one of the parameters. We make sure that the value is between 0 and 9999. This should probably be a U at the end here just to be explicit. And then we are grabbing that, we're logging the counter that we are sending. So we'll say sending counter 0, 1, 2, 3, or whatever the counter is. And then next we're putting in a buffer. We're going to start with %s is the game name. And then %c is the purpose. So that's going to be, the game name was subdemo : the purpose is C, the version major A. The counter to send is this %04u, so that's going to be 0042 or whatever value you have. A colon, and then %s is get the name of the flipper. And then end it with /r/n so that the message could show up using the chat CLI application. And then now that we have that buffer set, we are going to go and do this broadcast, which was this method we just looked at. Next up is broadcasting a tone, which is really similar. We have a frequency of the tone we want. We log the frequency, and we are going to put the game name, SG Demo : the purpose, the major version, which is the A. The purpose was the T for tone. The version was A. %u is going to put a frequency that's unsigned, And so if the frequency was 5, it would just write the number 5. If the frequency is 440, it'll write 440. This is a variable length packet depending on how big that frequency is. What you want to make sure is that when you do this kind of thing, that the largest frequency possible, the largest value, is still going to make the message fit in the maximum size you set. So, and then this last thing is the name of the flipper. And then we again call back into that broadcast method with our buffer. Cool. So we're almost done. The last piece is the entry point of the application, which is really 3 main parts. The first part is all the initialization stuff. So the frequency right now is hard coded to 433.92 megahertz. I have an idea of maybe we should have like an array of these things. And if it comes back with not allowed, we would try the next frequency in the array that our app was trying to transmit on. And then at least if 2 flippers are zoned for the same region of the people that are in the same room, then it would probably end up with both of them having the frequency in that value. So just an idea so that we could have multiple frequencies we try. If we do that, we definitely would want to have demo context data frequency property and be able to show this frequency on the flipper screen so that they could understand why it wasn't working if it wasn't working for them. Or give them a way to configure it, maybe with left button or something to change their frequency. And then depending on your country, different frequencies are allowed. So 433 is a common frequency that's used in a lot of countries, as is about 315. So those are 2 really good hard-coded values if you're going to use a hard-coded value. If you really want global reach, though, you do need to configure it. And again, 2 flippers, someone might be running different firmware that unlocks stuff that's not where they are, or one person might be visiting from another region. So it's a good idea to allow people to configure that frequency and not hard code it. This is just a demo. This is why it's hard coded. We're going to allocate memory for our demo. We're going to allocate a mutex so that when people try to access that demo, they can acquire and release the mutex. This is the data for within the application context we're going to allocate. And then we have that buffer that we're using for our UI we saw. Our local counter is going to start at 0 and keep incrementing. Our remote counter is going to start at 10,000. And our UI is only going to render if it's less than 10,000. So this won't display anything. Hopefully, let's go back up and check that one more time. Yeah, so only if it's less than, so since it's equal, this code won't run initially until we actually get a packet. Okay. And then we create our queue. And this should probably say for tick or input or receive or send or there's all kinds of events now. So this part is a bug and should be removed. We allocate our sub-gigahertz worker. Okay, so now that we've allocated our worker, we try to start the worker on that frequency that we know we can do transmit on. If it succeeds, then we register this callback that we have with the worker. So we tell the worker, call this callback, passing our demo context every time you have new data to read. If we weren't able to start the worker, then we should at least log a message here that says we couldn't start it. So that's probably a good idea to add. But yeah, we couldn't start it. We exit out the application. Ideally, we would let the user know that we couldn't start the worker. And then potentially, again, even when it doesn't start, maybe we would want to switch back here to another frequency and see if it could have started if we were on a different frequency. That's just more things to think about in a real production application. Okay, so all the CLI apps did this disable charging. So we're going to go ahead and do suppress charge enter, which disables charging and increments a count of how many people have called this method. At the end, when you re-enable it, the count goes down, and if it gets back to 0, then they start enable charging. I'm not really sure why we're doing this with the code and if it's related to sub-gigahertz or not. I'm just they all did it, so I'm doing it. Post in the comments if you have any feedback there. Okay, so we allocate our viewport. For drawing, we're going to call that render callback that we wrote. And when a button is pressed, we're going to call that input callback. So remember, the render callback actually drew to the screen. The input callback queued a message up of demo event type key and put in the event.input with the message that was being sent. And so that's why we're sending this queue context to it. Next, we're going to do our record open for the GUI and then go full screen. Next, we're going to allocate our timer. It's a periodic timer, and we are going to start that timer off every 250 milliseconds. And when that happens, that's going to call our callback, and our callback is going to put in this demo event type tick into the queue. That's what that's going to do. This is our main message loop. We grab something out of the queue, and then based on the type, if it's a key, we say, oh, is it a short key press? Yeah. Is it the OK key? Yeah. Okay. Acquire our mutex, send the count because they pressed the button, ask for a send, and that's it. Release it. And so when we go there, we've already looked at that, but let's go ahead and look again real quick. So we said send a count. And what that's going to do is grab the current local counter and put it as the number. And that's what's going to get queued. So we'll have a demo event send counter message, which we'll see down here. And then if they press the up button and it's short, or short and it's up button, we send a tone at 440. And again, send tone, what that did, and we passed in 440. What that did was queued a demo event send tone with the number of 440 or whatever value we passed. And you can see that the next thing is if it was a long press with the up button, we send the tone with 880. And then if it's the back button, we set processing defaults, and that way we'll exit our main loop and clean up our resources. Okay, so tick. Remember here that we told the timer every 250 milliseconds to go ahead and invoke this callback. This callback queues in a tick event. And so 250 milliseconds, this tick event will show up in our queue. So we go ahead and we are going to update our local counter on the tick event. So we increment it. And then again, this should be greater than or equal to. We're going to wrap it so it's always a 4-digit number, and we're going to log that. When we are doing rendering, we'll see that new value. So then this is with the send counter and the send tone, which we saw that these events again happen when we did send counter and send tone. So when we have a send counter, we are going to go ahead and say sending the counter and then broadcast that buffer and use the worker to send that counter. For sending the tone, it's the same thing. We're going to do this and send the tone. The event data detected event here, you'll recall that when we started our worker, we registered a callback whenever we got new data, and that callback did the demo event detected, put that in our queue. When we have information that's there now, we're processing that. We're going to go ahead and receive the data, check if it's a message for us, and if it is, we'll figure out what kind of message it is, and then we queue up work to do like received a counter or received a tone. And then if it was received a counter, we are going to make sure that the number is, this should be, we think a U at the end here, number between 0 and 9999. And then we log that counter value. We also set in our data the remote counter to the value that was sent to us. If instead we're at play a tone, we look at the event number and say that's the frequency we need. We log the frequency and then we play the tone. Cool. Here, it's probably good to log that we have an item in the queue, an event in the queue we don't know how to handle. Maybe it's even more critical to log that so that you know to deal with it. Finally, if we had a sender name in the event, which happens on, when we were processing message, I think here. Yeah, so here we did an allocate of name and we put name into sender name. So this sender name has an allocation. If it's set, we want to do a free. And then we also refresh our screen, which at some point later will end up invoking our callback for the screen. If we weren't able to get a message from the queue, we had to wait forever, so that's not good. So we exit. We probably should log why we're exiting as well. Okay, and then we are freeing all of our resources. If our TXRX worker is running, we stop it and we free it. For all the other things, we're freeing them as well. And then don't forget on the exit path to re-enable charging. So, yep, so that's it. It's been forever, and I have been talking without recording. No, I have been talking with recording. So, good news there. Okay, well, it looks like we're at the end of the file. So hopefully I can go back and edit the file to have some of these changes we've talked about. So it may look slightly different by the time you look at it versus what's in the video, but hopefully make those bug fixes. And then, yeah, if you have any questions, comments, love to see that feedback. Let me know if this was helpful at all, because it did take a while to make. So if it's 0 people find it helpful, I probably will avoid doing these in the future and just focus on shorter videos showing one particular aspect and not walking through my code. I'm going to be making some more applications. So if you found it helpful and you want me to walk through more code, then let me know that too. Really appreciate everyone's time today. Thanks a lot. Look forward to having you see some of the other videos. Hopefully this gives the community a good starting point to make some more multiplayer, multi-flipper device applications. Great. Thanks a lot and have a great day.